Okay, so the meeting notes are on the chat. Please feel free to add yourself to the attendees list and follow along. So welcome to the Network Service Mesh meeting. We hold this meeting every 8 a.m. On Tuesday Pacific time. And we also hold a developer and PR issue, which occurs every 7:30 a.m. Pacific time, a half hour before this particular event occurs. We also participate in a number of other organizations or other groups, including the CNCF Telecom User Group, which the next call will be on Monday, April 5th at 1500 UTC. We also participate in CNCF SIG Network, which occurs every first and third Thursday of every month at 11 a.m. Pacific. Major events coming up. We have KubeCon Cloud Native Con EU. The schedule should be announced already. If it isn't, then it will be around very soon. The event will be on May 4th through 7th. And we also have CFPs open for KubeCon Cloud Native Con North America, which will be in Los Angeles. That will be held October 12th through 15th. CFPs close in April, so don't wait too long to get those in. So in terms of the social media community, we have an additional follower and 2 additional followings, and we have posted information about KubeCon EU and that the CNCF is also welcomes 47 new members. So it definitely continues to grow. With that, on the agenda, Denise, did you have something to show for today, or was that something we were going to wait on?
Oh, yep. I think we can show in short how we can touch multi-repo NSM today.
Cool. So please feel free to share and show us what you have.
Okay. Let me a second. Recently, we have finished examples for NSM multi-repo. It is a repository network service mesh deployments Kubernetes. And this is a repository in progress and will be updated with new examples and probably new architecture of folders, for example. But currently, this repository contains 2 things. The first thing is applications. It is just a folder that contains another folders with applications, for example, with forwarder and forwarder. It is just a YAML file for Kubernetes and a customization file that making this forwarder usable with customization feature from Kubernetes. And second thing that we have in this repository, it is examples. So to run examples, the first requirements that you should have, it is just a running cluster. If you have not a cluster, for example, currently I have not it. Let me show it. So on my machine, Kubernetes server is not running. So for run it, you can just look at our integration Kubernetes kind repository. And here we have a prepared cluster configuration to run kind cluster. So let's do it. Let's just start with kind cluster. In short, while it is cloning, we can take a look. Oh, it is done. let's start it. To start it, it is just simple. I need to go into this directory and run this command, just copy paste. Oh, also probably if you have not a kind tool, you can, oh, sorry, I need to delete my previous cluster. If you have not a kind tool, you can just Google it, and the first link should help you to get a kind tool. So let's again copy paste this line into my terminal. And while it is starting, we can return to deployments repository. And let's a little bit look at examples. Currently, we have two suites. In general, it is a basic suite and a memory suite. The main difference is that in memory suite, we are using registry memory setup. In short, memory suite, it is just set up an SM manager, forwarder VPP, and registry memory. When example basic, it is contains also an SM manager, also forwarder, but using registry Kubernetes. So we can start with any suite, what you want. For example, let's try to run a basic example. Let's a little bit talk about example structure. Mostly our examples have three required sections. The first section is includes. This section means that all examples located in this by this link can be run after you run section in your terminal. Also, important thing, it is requires section. If you see in the example that it is requires something, you need to just go to it and follow steps from the run section. So also to run examples, we need to clone this repository. Let's do it. So it is cloned, and let's go into examples, basic. And here we see that this example requires Spire setup, so we can go into Spire. Let's go here also in the Spire and just follow these steps. Just copy paste. So currently this line is deployed. All stuff that is required for Spire. The stuff is you can find the stuff in the customization Spire customization file. Here we can see resources that currently applied here, and now we can check that all applications have started. For this, we can just run this command that just check status. For example, currently, as I understand, Spire is downloading. Let's check it. So it's my first time to run this example on this cluster. And as you can see, I have not images on the nodes, and that's why it is loading. Okay, looks like Spire is done. So now we can register Spire agents. So just copy paste the second step. Spire agent is registered, and let's continue to run a basic example. So I have done a requires section, and now to run examples from includes, I need to run this section. So let's go into basic and just follow the steps. So the first line, I'll create an NSM namespace. Currently, it is not a requirement that you need to run an NSM in NSM namespace. It is just, for example, let me demonstrate it. So current customization file from basic example uses manager forwarder registry Kubernetes, and it deploys it into NSM system. So actually, you can run in NSM in any namespace. It is not is a critical requirement. Okay, let's return to run example. Yes, for last comment, I registered an SM namespace in the Spire. And the second step, I need to register my registry Kubernetes service account in the Spire. So let's do it. And now we can apply all applications from the customization file from the basic. So as you can see, an SM manager forwarder registry Kubernetes have created. Let's check this. And as you can see, we have a namespace NSM system, and let's get pods from this namespace. And here we can see that all applications starting. I'll remind that currently my cluster have not images. It is just downloading right now. And while it is downloading, we can go into probably applications. And here, one interesting thing about registry Kubernetes. Registry Kubernetes is not trivial as other applications because it using our CRD custom resource definitions. For example, network servers and network servers endpoint. And when registry Kubernetes applied via kubectl apply -k, it applies also CRDs and roles for using API server and also server's account and so on. So let's check status of my NSM applications. Also, the main feature of new NSM is that we actually do not need to wait all applications done. So while it is creating, we can actually go return to basic example. We have run all steps from this, and now we can run any example from the includes or features, for example. So I think we can get this simple example, for example, kernel to kernel connection. And here we can deploy this example about deploying client and endpoint that will use that will deploy on the same node, and will use a kernel mechanism to connect to local forwarder. So let's check status. Oh, fine. All applications are running, and we can start kernel to kernel example. So to run this, we just need to go into this folder. This use cases kernel to kernel. And here we just need to run all commands from the run section. Let's do it. This line is created namespace for client and endpoint. Let's check this. Oh, sorry. Yes, and it is not applied. Let's do this again. And oh, sorry. And now we have two namespaces. The previous command have done correctly. Let me check that current namespace that we'll use into example. Okay, so we can delete redurrent example or redurrent namespace. It is this guy. We can remove it. So we have created namespace for client and endpoint. The second step is we need to register this namespace in the Spire agent. Let's do it. Okay, so example about that understand and endpoint can connect to each other on the same node. So to this we need to select node to deploy, and this command will do this. So let's just copy paste this, and let's check what we have in this variable. As you can see, we have selected kind worker node. Let's check all nodes. Okay, I have 3 nodes right now, and we expect that a client and endpoint will deploy it on this node. Okay, the second step, we need to create a customization patch. So previously I show applications folders. So customization feature from Kubernetes allow us to merge YAML files. For example, let me run this to commands, and I'll show how it is working. So we have created customization file. Oh, let's just run this and just check what we will have in the directory. So currently my folder has a customization YAML file. Let's check what it is. Oh, it is just customized config that includes basis applications. Basis applications, it is NSC kernel, NSE kernel. Let's check what it is. It is NSC kernel. NSC kernel is just a deployment that using CMD NSC image. And this customization file just means that for this application, NSC kernel, and for NSC kernel will be applied patch NSC YAML and patch NSC YAML. Let's check what it is. NSC patch, it is just part of YAML config for NSC. Let's again look at NSC kernel. So NSC kernel will be merged with this. In short, it will add into this YAML file dynamically. It will be done. So it will add additional environment variable, NSM network services. That means which servers our client will connect. It is it's a responder, and we'll use a kernel mechanism. So, and let's look at our patch for NSC. And this patch is just meaning that NSC should use this CDR prefix to create to generate IPs for the client and endpoint. And also it has this two patches have selected node. So this is required because we went to check that connection is working fine on the when client and endpoint is deployed on the same node. So let's return back to the example, kernel to kernel. And so now we can just apply the customization file that will apply these patches for NSC and for NSE, and will apply them into namespace that we have created before. Okay, let's just run this. And as you can see, NSC and NSE are created. Let's check this. Let's get pods from our testing namespace. And as you can see, client and NSE has created, but it is creating actually. So the next command just wait for status ready for this applications. So as you can see, applications is running, and now we need to select client and endpoint by variable to use a short syntax. And now we can check that NSE have created two IP addresses for the client and for the endpoint. And we need to verify that forwarder also have created interfaces in the client and in the endpoint. And to verify this, we need to just ping from the client to the endpoint IP address. IP address we have defined it here. So let's check that we can ping from the client to endpoint. And as you can see, ping is working fine. And now we can also verify that NSE can ping the client. Let's run this. And as you can see, endpoint also can ping it. So we can just a little bit play with these applications manually. So let's just get pods from this namespace, and we can just, for example, do exec, for example, for NSC. from namespace and we can check ipconfig or if config. And as you can see, for client, we have NSM have created NSM namespace and NSM interface, NSM1. And we can see statistics here and so on. So why a client have interface that have name NSM1? It is also, we can find in our patches. We can see it here, that value of our network services is kernel. It is a mechanism that we are using to connect. It's in responder. It is a default name of our testing application. We also can a little bit look at it in deeper. We can go to simple responder in C and look at source code. Let me find it. So in short, it's simple responder that we use it in this example is described by this main file. And here we have environment config. And here we have a default name of for service for this endpoint. It's simple responder, and that's why we are using in patch for NSC this value. So and NSM1 it is a name for names for interface that should be created. So and as you can see, it is working fine. And
can I ask one question? Jan speaking here.
Oh, sure.
I see that it looks like a /32 IP address that has been assigned to NSM1 interface. So has there also been routes injected into the NS client pod to enable communication?
You mean two addresses for NSM1 interface?
Yeah, the address, the 172.16.1.101 is a /32 address looking at the mask. And I'm wondering, where's the routing configuration for this to work?
It is also is a feature that we have added that we are using static routers. Actually, we can connect to interfaces with this mask. I guess we can also go into NEC application and check IP address and so on site from NEC. And here we have IP address without one. And as I understand your question about why we are using mask 31, is correct?
Not exactly. What I'm asking is, I mean, the interface that is configured in the client and the same on the server side is a /32 address rather than a /31 address or a /30 address. And that means it can only work if you also configure a static route. And I was wondering, can you show that static route and can you explain how this is installed?
Oh, yep. Let me check if Vladimir on the call. I guess he can say more.
Yeah. Yes, so we are configuring static routes. to make it accessible from one to another. So forwarder is doing all the stuff, injecting interfaces and routes.
Is this now the general rule how this works, or is this specific for that type of service?
No, it's in general for all services for kernel mechanism.
Yeah,
Okay.
to be clear though, if you have a different path, a different way you want to do it, we don't stop you from doing that. For the for this particular one with the /32, the we needed to add in the routes in order so that way it knows where to go, and it's done like that in this specific path. But if you have a different way you want to do it, then we wouldn't stop and your system from handling its use cases in the way that it needs as well. Is there a special requirement that you have here that we perhaps may have overlooked?
No. I'm just curious because apparently it's a change compared to what we had before, right? In the old NSM, the interfaces that were injected into the pod usually were not /32, but they were /something, and there was a connected subnet route automatically created to allow communication between server and client. Or am I completely wrong here?
No, you're correct, and this was a move that we wanted to head towards. The reason why is that it helps improve the total the total consumption of IP addresses, and so the way that this one is specific to there's a point-to-point IPAM that's used in a reference that's in the reference implementation. And you can replace the IPAM with something else if you want. So if you want to pass in something less than the /32 and handle it in a different path, then you're able to achieve that. But
okay, so it's really up to the server to specify what IPAM it wants. But if it chooses this point-to-point IPAM, then the forwarder has special logic to translate this into /32 addresses with a static route. Is that what you're saying?
Pretty much. Now, I don't recall if the routes were added to the actual NSM message, so that way it knows what to add, because you may have other routes you want to add as well. So it's not, it shouldn't be a special case in that scenario.
Right.
It's more just a configuration path.
Okay, yeah, good. Then I understand.
I'll need
okay.
I'll need to validate that though, if just to be 100% sure. But that's the way it's set up. And from an implementation perspective, just for your own knowledge, what we use for the IPAM point-to-point IPAM is an algorithm called roaring bitmap. And what this does is it gives us the ability to find the smallest address that is not used in constant time. And so that gives us the ability to, and we're able to also combine them together, so that way we can say, based upon information you have, information that addresses you've used, and addresses I've used, what is the smallest set of addresses that we both can consume? And so it makes that use case fast, and it allows us to use things like link local addresses, where you're not concerned about deconflicting everything. You're just concerned about, like, what IP addresses from my side should you not conflict with? What IP addresses from your side should we not conflict with? And as long as we can find a intersection between those between what's available on my side and your side, and then we're free to proceed. And so this allows us to reuse IP addresses in scenarios where historically we couldn't in a safe way. And because the IP address is no longer the identity of the service, instead IP is how you route to it and how you communicate with it. But the identity of the service is defined by your SPIFFE identity. So you always know who you're talking to, and so you no longer have to rely on the IP port combination for your service's identity. And so that, because of that decoupling, that gives us the ability to get some significant reuse, which is helpful in environments that are IP starved. So for example, one of the large organizations that I work with is running into this exact problem where even in their 10x network, they're struggling and doing very careful management. So this is an escape path for some of those issues.
Okay, thank you. Thank you.
Sure, my pleasure. Denise, please continue.
Oh, okay. We checked that client and endpoint can ping each other, and now we can a little bit look at examples that we currently have. Currently, we have just examples for combinations of mechanisms. It is just about connection memif to memif, kernel to kernel, kernel to memif, memif to kernel, kernel to VX1 to kernel. It is kind of remote examples, memif to VX1, and so on. Also, we are planning to add examples for our features. Currently, we have one example for open policy feature. In short, this is about that client with invalid token cannot connect to the manager. In short, here we can see a stream that in general shows how client requests to endpoint. So at first step, client put into request his token. Second step, client request endpoint. Endpoint adds the token from the client into pass. It is structure from the requests. And after this, endpoint validates all token in the pass. So this step, this example shows that at step 4, for invalid client, endpoint will return error. This situation can be happen on any node of NSM applications. For example, this situation can be happened when NSM manager will try to request to forwarder, and when forwarder will try to request manager, or when manager will try to request endpoint. It is in short is step 5. Oh, sorry, step optional when endpoint should go to the next application. In this case, endpoint will do step 1 as it's doing the client. If you want, we can look at another examples. So what do you think?
Yeah, we have another 15 minutes. So if you want to show another example, let's go for it.
I guess we can look at remote example. It is should be fast because we already have deployed Spire and NSM. So we need to just to delete our namespace with client and endpoint with local connection. So, and probably, I guess we can run this example with open policy. So So here we'll inject into client config. We'll inject value for token lifetime. We'll make it negative to make all generated token from the client are invalid. To check that the first endpoint in the path will abort request. Probably you have any questions to this stream, for example, or something else. Okay, so let's just quick run this example. For this, we need to go into features, open policy agent, and just copy paste steps from the run section. Here we have created a namespace. We have registered this namespace in the Spire. We have selected nodes, and we need to create patches for understand endpoint applications. Let's do it. And now we can apply it. So let's check. Currently, we have created a namespace for the next example, and we have deployed a client and endpoint. So I guess we can quickly check that it is that OPA is working. We can get ports from this namespace, and I think client already has restarted. Yes. So client restarted because of a manager aborted request. Let's look at logs from the client pod to verify that. To verify it. So, and as you can see, the error, it is that that permission denied. So it means that our manager have validated a chain of tokens, and it checked that a token from the client have invalid expiration. So I think we can find it in the logs. We can, let me second. Oh, it is a config of environment variables. And here we have max token lifetime is negative. So example is working correctly. And we can also check logs from the manager. Oh, also we need to we need to find a node where a client and endpoint have deployed. Oh, sorry. Yep, and we can see that it deployed on a kind worker node. So now we can get pods from NSM system namespace, and we can get logs from the the manager that are located in the same node, a kind worker. So probably we can check here so many logs. So probably we can find this validation in the logs. As I can see, we have part of logs. So NSM manager got too many logs, and looks like we can't find this entry of a request from invalid client. But it actually will retry to connect. So probably we can just wait for the second request. So if you have any questions, I'll be happy to respond or answer.
Yeah, thank you for showing this off. And so for reference, this is on the GitHub network service mesh deployments-Kates, deployment-Kubernetes. So feel free, so if we could copy and paste this these links onto meeting notes, that'd be fantastic, so people can give it a shot. And this is testable using kind, Kubernetes and Docker. So if you don't have kind, then you can search for Kubernetes and Docker. It'll show up as kind.sig.kubernetes repository, and it's relatively easy to install. It's a single binary, and it'll spin up multiple clusters for you, and it'll allow you to run these examples as well. And these examples should also work in other environments. So we should see them work in environments like Google and Amazon and similar. We're going to continue ramping up the integration test in order to continuously validate this over time. With that, are there any other short topics that anyone would like to bring up or discuss?
Just got a short question about running a system with multiple forwarders simultaneously. Has that been tested in any way so far, or?
Denise, do you know the answer to this?
Oh, yes. Currently, NSM should support multi-forwarders, but actually we have not examples for this. So if you are interested in this scenario, you can just create an issue in the deployments K8s repository, and we'll add example. Currently, we have 2 forwarders. At this moment, we have a forwarder for VPP and for SRIV scenarios. Also, I want to a little bit talk about our testing. Johan, do you have any other questions?
No, it was mostly that. Yeah, thanks for the input. We're definitely interested in that. So yeah, we might create a ticket then.
Oh, cool. Thank you. So
right,
about our testing, all examples that I show today can be generated into Go suites. I can show it in short. For example, yesterday I have added example for open policy. Let's go into deployments repository. And yep, here is PR where I added OPA example. And when this have merged, have been created PR into an integration test repository. Let me try to find it. Oh, it is here. Yep. Oh, actually, I can't find it from the deployments repository. Okay, let's go into integration tests again, and let's go into commits. And I guess this should be in this commits. Oops. Okay, let's check all. Oh, I found it. So in short, how our integration is working. I just have added README example with open policy. And when PR have merged, our NSM bot have created a PR into integration tests. It is here. NSM bot have generated a new test with OPA in the integration test repository. This repository just contains all our tests in Go format, in Go code. It is just steps from the examples that just run in the terminal, but automatically. This PR have created, when this PR have merged, NSM bot have created the second PR into integration Kubernetes kind repository. And after this, CI have started with this example on the kind cluster. And we also can find logs from the examples in the kind job from the CI. So as you can see, ping also is working correctly here. So mostly that's it from my side.
Yeah, this NSM bot is actually quite nifty. So this actually works across all of our repos. And so if you commit something into, let's say, SDK, then it'll cascade those changes into the other repositories and make sure that they work as part of the process. And so this allows us to catch problems downstream and bubble them up as failures while you're working on it. So this worked really well with our code, and so we then turned it towards our CI CD path for integration test, and when you tie it in with the markdown and with the executable markdown that was shown before, where each of those lines gets executed, this turns into a very nice combination to make sure that the documentation doesn't just work at the time of, well, presumably the author tested it, but that also ensures that they are working even over time. So if you have a specific use case that you find important, and if you create a markdown of it, and which includes instructions on how to replicate that use case, then that is a potential for ending up in our CI/CD system and ensuring that happy path is always tested, or failures if you want to test failure conditions. Anyways, we are at the top of the hour. With that, I want to thank everyone for attending, and thank you, Denise, for the fantastic demonstration. And we will see you all again at the same time next week. Take care.
You.
Yes, thank you very much for the excellent demo. Bye.